Welcome everybody to another live stream repair. Hope you all are having a wonderful Monday. We've got one HomePod today from Jesus, and they're saying it's got death farts. So let's get that out. Ugh. Here we go. Put their packing material to the side here. And let's get ourselves a drink. Today we've got Vortex IPA from Fort George. Let's see how that is. Yeah, not bad. Ooh, not bad at all. Okay. Let's get our cameras situated here. And let's plug this into some power. Obviously, based on what they told us, it has death farts. We're expecting it to turn on fine here. However, with death farts, the cause of that being too much DC going through the amp and into the subwoofer. One of the things that we can look for here, just to double check, is powering it on and listening for how severe the pop is when it wakes up from standby and turns the amplifier on for that first time. So we're powering it up now. We're gonna wait for it to finish booting, and then we will do something that triggers it to turn the amplifier on. Because on a cold boot, the amp doesn't actually turn on yet. So here we go. It's booted up. Let's trigger that amplifier on and listen for the pop.
I'm happy.
Yep, that's a decent pop. And then also when we unplug it from power after about half a second, we should hear another pretty healthy pop. Yes, indeed. Excuse me. So based on those symptoms alone, we don't need to sit here and factory reset it, set it up with our phone and play music through it until it farts on us. Just based on experience, I can hear how loud that pop is and kind of guess that we've got at least a couple hundred millivolts, if not more, of DC offset being produced by this amplifier. The reason why that happens is there are a few tiny little filtering capacitors on that amplifier that are supposed to filter out any unwanted DC before the audio is amplified and sent to the subwoofer. These caps like to lose their effectiveness over time and slowly allow more and more DC to the subwoofer, and that DC is the popping sound, or that DC will result in that popping sound you hear. So for example, we've got a 9-volt DC battery here, and if we just connect that to our speaker here, we can effectively we can basically imitate our DC offset issue and basically what the amplifier is doing to our subwoofer here. So we get a pop, and we see that the subwoofer moves and changes its natural position to quite far off the middle. So that can overheat the speaker and kill that subwoofer speaker. This can put additional load on the amplifier, making it work harder than it needs to and fry components on there. And of course, it results in that popping sound that you hear. And when this DC voltage gets so bad, the components inside will cause these death farts. So let's get this torn apart. Enough talking. See if we can't diagnose for sure what's going on here once we get all the parts out, and then do some repairs. Before we actually fix anything, what we'll do is gain access to the amplifier on the inside, and we're going to connect that amplifier up to a multimeter and our subwoofer here on the desk, just to gauge how much DC offset this thing is producing, and just to double check and make sure that we are correct in our assumptions here. Lots of mumbo jumbo, I know, but all you guys need to worry about is audio is an AC signal. DC is not desirable in your audio signal. And there's an inherent amount of DC voltage that's going to be introduced in your audio signal with any audio amplifier. That's just the nature of taking ones and zeros and converting them to an analog signal that your speaker understands, and then amplifying or boosting the volume of that signal. That takes power, and some of that DC from that amplifier will make its way into your audio signal, and that's what these capacitors here are supposed to filter out. And over time, be it because these are poor quality capacitors, or they weren't properly picked for what they were supposed to do here, and by that I mean maybe Apple was supposed to use a different specification for capacitors here. In any case, these capacitors that are used to filter this DC offset, they are naturally going to lose their effectiveness over time. One way or another, it's natural and it's inevitable. So, at some point in time, they will continue to filter less and less DC, and eventually your HomePod will fart. And eventually you'll need to do the repair similar to what we're doing here. It is a sad but fixable fate for any HomePod. Let go. Come on. Access to the subwoofer, so we can double check the condition of that real quick. Voice coil looks good in there. Subwoofer still feels nice and smooth, and it still smells just fine. Welcome to the stream, first of all. To answer your question, you can't buy the amplifier board. You have to buy broken or working or otherwise, you have to buy basically a HomePod one way or another in order to get your hands on another amplifier board. That'd be really nice if you could just buy these amplifier boards. But, unfortunately, Apple does not like it that way. Okay, so let's just do a quick visual inspection of this board here before we do any repairs. Or any testing. So there's our power diode. That's usually what shorts out and causes our no power issues, although this one is powering on fine. We're going to replace that diode regardless, just because this diode loves to fail so often and we're not sure exactly why. We have our guesses, but we just like to replace that diode in every HomePod that comes in for repair. If we look next to the subwoofer connector there, our 10 ohm resistor seems to have catastrophically failed. Wow. So we'll go ahead and get this replaced. Everything else looks good. Flip the board around. Everything looks good here. Okay. So here's what we're going to do. We're going to put this together on the test bench real quick before making any repairs. And we just want to get a baseline idea of how much DC offset this amplifier is producing. We're expecting to see at least a couple hundred millivolts at the start, and it should grow over time past 2 to 3 volts, which is that threshold that causes the death farts. Once the amp sees like 2 to 3 volts getting sent to the subwoofer, it forces a restart, which results in that farting sound. Okay. Alright, so we've got our multimeter connected to our subwoofer here, which is plugged into our amplifier here, which we are now going to plug into some power and see what we've got going on here. Okay, so board is booted up, and like I said before, the amplifier does not turn on after a cold boot, so we got to do so. And oh boy, alright, we're well past the 200 millivolt scale on my multimeter here, so let's go ahead and jump that up to 2 volt DC scale, and we can see a rather rapidly growing 650 millivolts, 660, 670. That's going to keep growing until it reaches 2 to 3 volts DC, in which case the amplifier will see that and then death fart and force a restart. So what we want to see after we do our repairs is this number to stay below 50 millivolts. And that will get rid of our death farts. And that is a loud pop. Goodness. Okay. Let's get this board taken care of. Alright, first thing we're going to do is replace our filtering capacitors. We know for pretty much a fact at this point that these capacitors right here are what tend to go bad and cause more of that DC to go through and show up on our meter here. So we're going to get those 4 capacitors replaced first. And then we are going to replace that resistor on the other side that was obviously blown up. And then we'll wrap up by replacing the Schottky barrier diode, which doesn't have anything to do with our death farts here again, but we just like to replace that diode in all of our HomePods to hopefully prevent that pesky no power issue. So I'm cool like that, and I like to pluck them off 2 at a time. Makes it a little quicker. No harm either. We're gonna get some flux on the board. Grab our soldering iron, and we're gonna tin these pads up with some low temp flux, or low temp solder. And when they start doing that kind of funny business, gotta put more flux on there. There we go. That'll do the trick. Let's grab some fresh new capacitors from our parts here. I've got all of the parts that I use for my repairs on my website at nixfix.com. Check out the common issues section over there. Find your issue, and I'll have information on how I diagnose and repair that, along with the part numbers that I use when I replace any of the part components on here. Okay. Fresh filtering capacitors have been installed. Let's flip this around, knock out that resistor over there. I'm going to grab our custom-made metal shield here that covers up the plastic subwoofer connector and the capacitor right next to this resistor here. There we go. Let's grab a new one of those. That should do. Alright, last but not least, let's do that preventative maintenance there. Let's get that power diode replaced. And then we'll be ready to test this board. All right. Oops, goodbye. Hello again. I see a little ball of solder in there. I'm gonna get you. Got him. Okay. Let's let this board cool down for just a minute here. And we will retest and see if we got rid of that DC offset. Alright, is that cooled off enough? Sure. Alright, let's see what we got. at that. That's gonna keep falling until it normalizes, probably at around 10 millivolts flat there. This is a significant improvement from the 600 millivolts and growing of DC that we saw earlier. Excuse me. So, I am pretty certain at this point that, yeah, that's going to hold pretty steady there. Awesome. So, we've got the source of their death farts fixed. Let's get this thrown back together. Do one last sanity check with all the parts put together, and we'll be all done for the day. Yeah. Excuse me, I forgot that I was even streaming for a second there. Forgot all of my manners. Thank goodness. if you look real close, we almost went and put our touch cover back on here, but looks like the volume button's being covered up just a little bit. There we go. That way when we go to put this cover back on, those buttons will light up nice and evenly. Alright, let's see what we've got here. Drum roll, please. Very nice. First try. Alright, let's check it for sound.
I'm having trouble connecting to the internet.
No severe
For more
popping.
info, check the home app. I'm having
And our volume buttons, they light up nice and evenly. So, this HomePod is all ready to go. I'm going to go ahead and leave it plugged into power here until I pack it up later this evening or tomorrow morning, just to be sure that it doesn't keep farting on us in the background. But based on our experience and what we saw on our meter here, we've got every reason to believe that we've got our death farts repaired on this HomePod. And for good measure, we've got a new 60 volt 5 amp Schottky barrier diode on that amplifier to hopefully prevent any of that oh so common no power issue that plagues many other HomePod owners. So that's all that I've got for you today. If you have any questions about this or any of the repairs that I do on HomePods, you're more than welcome to leave a comment down below or head over to my website at nixfix.com, where I've got all of the common repairs that I do, how to diagnose them and repair them, and the part numbers that I use for those repairs, as well as my contact info if you'd rather just send it in to be repaired here on the channel. So, hope you guys all enjoyed, and I'll catch you in the next one. Goodbye!